Now, don't say any bad words, okay? The cross product is what you get if you multiply two vectors, so to make sure they have arrows on the ends, okay? Solid line, it's on solid line. So if I have one vector, and I have another vector, and then the cross product, we're going to make it come out this way, okay? The cross product is a vector that is perpendicular to both of the other two vectors. Okay, so if this is V and this is W, okay, is that right? V cross W, V cross W. Now I want to call this U and V. Call this V and this U. V cross U is equal to W, which is a vector that is orthogonal. They use orthogonal. That is orthogonal to both U and V. Well, did I draw that okay? Do you understand? So this would be W. So if I have two vectors, and these two vectors don't need to be perpendicular to each other, they're just hanging out there in space. And this third vector is a vector that is perpendicular to both of those. Okay? And
It's perpendicular.
How is V perpendicular?
How can it
What?
always be perpendicular?
Oh, I see.
how can it always be perpendicular to two other
W doesn't
vectors?
look perpendicular to
Uh,
all three.
What?
How is V perpendicular to W?
No, there's always
Because it's in three dimensions, right?
It's
Oh.
only two, so it's
So, now move on. Okay.
That'd be like that.
So the way you find the cross product, I'm going to change this to U cross V, because that's kind of what they use in the book. U cross V,
But if it's
but
this way, it's parallel.
you use the right hand rule. So if this is U here and this is V here, then U cross V would be your thumb. Okay. If this is U here and this is V here, and you go upside down, then U cross V is going upside down.
Wait, so they have to have the same initial point?
No. But just to show you,
Your thumb is W.
yeah, my thumb is W.
If these are the vectors, where's the thing?
No one's my vector. Most of the vectors were the thing.
I don't. Yeah, what Jackson just did. Okay. No, they don't have to have the same initial point. Okay. But in most cases, they will. Okay. So this is how you find it. Okay. U cross V is equal to. Do you remember this thing? Anyone remember what that thing's called? IJK. It's equal to U1, U2, U3, V1, V2. That's not a matrix, it's a determinant. Okay? So determinant is just, and all they're all going to be 3 by 3 determinants. So there's nothing longer than 3 by 3. And do you guys remember how you evaluate that determinant? Yeah, you cross out.
Yeah, you cross out one.
You cross out the row and the column. Okay, so
Fingers.
this is easy. Yeah, it's a determinant, not a matrix. Okay, so you just go like this. It's the smaller determinant. In this case, U2. This is that should be an equal sign. It's equal to, okay, U2 U3 V2 V3 times what? This, so I'm talking about this determinant here, times, yeah, I.
Yes.
Minus, it always goes plus, minus, plus, okay? Minus this, then you cross out the J column and the J row, and you have U1, U3, V1, V3 times J. Okay? And then plus, okay, the determinant, I cross out this and this, right? So what's left over is U1, U2, V1, V2, V1, V2, okay. And that's how you calculate it, okay? So let's just find the cross product between two vectors.
Wait, how do you know it was plus and minus?
That's just the way determinant is evaluated. It always goes plus, minus, plus,
Oh,
plus,
that, I forgot
minus,
about
plus,
that.
plus,
Okay.
yeah. So that's the way it always works. Okay? So let's do an example. So evaluates, or finds, it's not really evaluates, find U cross V if U equals, I try to come up with a little different one than's in the book. I plus 2j minus k. I plus 2j minus k. And v equals 3i. 3i. What's outside? Yeah, minus 5j. Hey, or 3i minus j plus 2k. I'm not very good at drawing cursive k, so I'm going to leave it like that. Okay? Ready? So we just plug into the formula, and so I'm just going to do the determinant, plug and chug, baby. That's the way it works, okay? I, j, k, 1, 2, negative 1 goes there. That's the components, the coefficients of those components. And then 3, negative 1, and 2, right? And then so you do this determinant, so it's going to be equal to the matrix, not the matrix, I said matrix, I mean determinant. 2, negative 1, right? Negative 1, 2 times I minus what? What's next? 1, negative 1, 3, 2, j plus 1, 2, 3, negative 1. 1, 2, 3, negative 1, k. And then, do you guys remember how you evaluate that? Multiply the diagonals and subtract them, right? So this one's going to be 4 plus 1, which is 5. No, it's 4 minus 1, right? Because it's 4 minus plus 1, which is 3, right? 3i?
Yeah.
And this is minus, you got to be careful here, minus 2 minus 3, which would make 5j plus negative 1 minus 6 is negative 7k. Yes? Which is 3i minus 5j minus 7k. So this would be w, if I would call it w, would be the vector that's perpendicular to both of those two vectors. Right? Isn't that cool? Easy. Easy to do, right? Now, what if I did
So the vector is 3, 5, and negative 7.
3, negative 5, and negative 7? If I did v cross u, do you think it would be the same? V cross u. Okay?
Yeah.
It's
Right.
negative.
It's,
No.
who said it's negative? Who said Ficker? How do you know that, Ficker? You read ahead in the book?
Yeah.
Negative 1, 2, 1, 1, 2, negative 1. If you did this out, you would get that this is negative. How come my colors didn't work? Shh. You would get negative 3i plus 5j plus 7k. So if you reverse the order, so order is important when you're doing a cross product, okay? If you reverse the order, you're going to get the opposite thing. You can kind of see, let's just do the first one, right? You get negative 1 times 1, negative 1 makes positive 1, minus 4 would give you a negative 3. See that? okay, and so on. So if you reverse the order, so I put
Ah.
V in front of W, then everything flips signs. And if you do it backwards, you're going to lose points. It's not exactly the same thing. Okay? So,
So it's always U times V. Unless.
no, if it says V times U, then you put the V first and U second. You see? So, yeah.
I don't understand what those equations at the top are.
These two things,
Yeah.
these are two vectors. So one
Oh,
vector,
okay, I thought.
so one vector says I go out 1 over 2 down 1, right? So if
Yes.
I were doing this vector, it'd be, I don't know, look something like this, right? This one says go out 3, back 1, up 2, okay? So if I were to start here, it'd be here. And this is the vector that would be perpendicular to both of those vectors. It's hard to see if you're not in 3D. Okay?
That's amazing.
All right. So, V cross U. So some properties of cross products. Cross products is that U cross, if we did this out, U cross U, what do you think you get out? What kind of vector is perpendicular to both to itself? There ain't none, okay? So if you do it, if you put it into the box and you did U cross U, you would get out 0, okay? V, here, do I need to take away your electronic devices? What? It's good, so put it away. Wait, we're not here to watch movies, we're here to watch math movies, all right? So, what? What happened? Okay, where was I before I was so rudely interrupted? V, so if you did U cross V, that's equal to the negative of V cross U, right? So that's kind of the property that I just told you. So you would get the opposite thing. If you did U cross, does that look like a U? I can't tell. U cross V plus W, that's equal to U cross V plus U cross W, which means it's the distributive property for cross product. So I could add two vectors together and then do the cross product, and that would be the same as if I did the cross product of this times this and this times this and then added them together. Yes? Understand that? Okay. What else? You can take a constant. I should change colors. You can take a constant and multiply it by a cross product. So C times U cross V, where C is a constant. And that's equal to the same thing as if I would have multiplied one vector by a constant. Hey, CU, go CU. And times V, which is also equal to if I took U and multiplied that by CV. So I could take that constant and you don't distribute it through both things. I could take that constant and multiply it by one of the vectors and then take the cross product with V, or I could distribute that C through the V and then take that cross product, or I could take the cross product first and then multiply it by a constant. Okay, so that's what that one says. Then you have U cross 0, where 0 represents the zero vector. The zero vector is I, J, K. You would have all zeros here, right? So I would have something like this, and I might have like 3, 2, 1 there for my second vector. And if I cross those two things, I would get out 0, okay? So that's equal to the 0 vector itself. We already talked about U crossing U being 0. And then lastly, the next property says that U dot V cross W is equal to, so can you read that? No. Okay. U dot V cross W is equal to U cross V dot W. So if I did this out, would I get a number or would I get a vector right here?
A number.
You would get a number. Because you're taking the cross, you're taking, this gives you a vector, and this is a vector, and then you're taking a dot product of that vector, right? And so this is a vector, and this is a vector, and then I'm taking the dot product, which gives you a scalar, right? So what this says is I can multiply any two of these vectors together, as long as I'm going in order. So I can take this times this and multiply by u, and I get the same answer if I get this times this and multiply it by w. Okay? Mason, got that tape on your butt, please. Okay? In the chair. Okay, then we have some geometric properties. Well, I know it's not much fun writing all this stuff, but geometric properties, you could just listen. Properties, you're going to have some time to work. Cross products. We already said that U cross V, the cross product is orthogonal to both vectors. But also, this is true. U cross V is equal to, the magnitude of U cross V is equal to the magnitude of U times the magnitude of V, whoops, there should be another bar there, okay, times the sine of theta, where theta is the angle between the two vectors. Theta equals angle between the vectors. So this is kind of, so probably if you're trying to find the angle between two vectors, this is more complicated than the one because we have another one with the dot product. So we had cosine theta, right, is equal to U dot V over the magnitude of U times the magnitude of V, okay? So this one is a little more complicated because you have to take the cross product, then you have to take the magnitude, but if you did want to find the angle, this would be another way of doing that, okay? You got that, Kaylee? Good. Okay. So that's good. The other thing is that so this quantity, the magnitude of U cross V is equal to, so this is one thing you're going to be tested on, is equal to the area of a parallelogram. And Mr. Beamer says he uses this all the time in his Calc 3 class to find areas of surfaces and stuff, because you take the integral and you add up lots of things. But anyways, so U cross V is the area of a parallelogram with adjacent sides, U and V. U and V. Okay, so now we're going to do some example problems. I know you want to do some example problems, or you just want to do your homework? Yeah, but you gotta give. I gotta give you some examples. Okay. Find. Okay, so the first thing we're going to do is find a unit vector. I'm going to use a blank piece of it. Find a unit vector. Do you remember what a unit vector was?
It's 1 unit.
1 unit long. Orthogonal to both U, which is going to be equal to, I'm going to write it this way, 1, -2, -3. 1, -2, -3. And V, which is equal to which is equal to 4, negative 5. 4 equal to this. 0, 4, negative 5. Could you do that?
No.
Yes.
Yes, you could. So the way you would do that, you would write I, J, K. You would write 1, negative 2, negative 3. You would write 0, 4, negative 5. And then you would find that, we'll call it W equals, I'm going to go kind of fast. Hopefully I won't make any mistakes. 10 minus 10 plus 7. Is that right? 10 plus 7 is 17 I. Did I do that right?
Wait, no, that'd be 12.
10.
10 plus.
Oh, you're right. 10 plus 12. You're right. Sorry. Thanks, Henry. 22. 22 I. Okay. Then I go this times this. That's why you shouldn't do this in your head. So it's negative 5 minus
Negative
0,
5.
right? So it's negative 5, which makes plus 5j, right? Because you can't forget, because the second term is negative, plus second component, plus 4 minus 0, oh, that's easy, 4k, right? So that's not the unit vector, because to find the unit vector, what do I have to divide by? The magnitude. And the magnitude of w, okay, is equal to the square root of this thing squared. So it's 22 squared plus 5 squared plus 4 squared, and it's a square root of that, which I can't do in my head. Can you do that in your head? I did it.
Yes.
It comes out to be square root of,
This is the magnitude of W.
yeah,
Square root of 525.
5. Does it come out to be 5? Yeah, I think
Square
so.
root of 525.
Five square root of 525, which is equal to 5 root of 21. And that's as far as you can simplify that. So the unit vector, u, the unit vector, so I guess since we went unit vector of w is going to be 22i divided by 5 root of 21. I guess you should rationalize that, but let's just leave it, okay? 5 over, oops, that's in the I direction. 5 over 5 root of 21 in the J direction, plus 4 over 5 root of 21 in the K direction. Okay? So that's how you find the unit vector. Should we find the area of a parallelogram?
Yeah.
We got it too.
This is the last one.
Make my graph.
Yeah, yeah.
No idea.
So, yeah, except sometimes, I want to show you something cool, okay? So, are you done with that? Find
Yeah, you took
the area
the axis is all.
Yeah.
of a parallelogram with vertices with the vertices at P 1, 1, 1, Q 2, 3, negative 1, R negative 1, negative 2, 2, and S at 0, 0, 0. Okay? So, anyone tell me how I do this? This is not easy, so I would kind of. So, I have to find the magnitude of two vectors that are adjacent. So if I were to plot these points, okay, in space 1, 1, 1. Okay, so let's say 1, 1, 1 is over here. It's kind of hard to visualize, right? So let's say this is point P. Q is over 2, out 3, down 1. So maybe Q is down here. R is back 1, back 2, up 2. So R is somewhere over here, right? And S is at 0, 0, 0. How do I know what that parallelogram looks like in 3 dimensions? You don't really,
You just
don't,
have to know.
you just kind of have to know. So about a time, on a test,
And have an engineer brain.
I think we're going to, but if they're adjacent, what do you know about the point from which they come? That, or if they're adjacent sides, PQRS, okay, they have to start from the same point, right?
Yeah.
Okay, so one might be PQ and one might be PR,
Well, PS.
and one might be PS, right? I don't know which one might be a diagonal of a parallelogram and which one in 3 dimension I can't really tell. Okay, so I could add this up minus plus this one, but it gets really complicated. So either you graph it in 3 dimensions. I'm going to do that in a minute, or they'll just tell you. Okay, and in this case, they're going to tell you that PR and PQ, PR and PQ are adjacent. PQ are adjacent.
So do
Are
they have the same initial point?
yeah, they have to have the same initial point, right? In order to them, right? Because they'd have to have the same vertex, right? So then I'm going to take the magnitude of PR and PQ. But first I have to find PR and then I have to find PQ, okay? So PR is equal to -2, right? This minus this minus this, -3, 1. Yes? Tell me if I make a mistake. PQ is equal to what? PQ.
1, 2,
1, 2, -2. Okay? And then you take the cross bracket, and in this case, it doesn't matter which order you do it in, because you're going to take the square of the square root of it, right? The square root of the square of the components.
Would
So
not be 0?
no, I don't think so. Cause they're
Yeah,
not,
I mean, it's either, I wasn't sure which one you were subtracting from, but I think the last
This-
one was supposed to be 0.
wait, this should be 0?
Weren't you adding them?
Wait.
Wait, did you just redo
PQ, -1 minus 1 would make -2.
that? Oh, okay.
Yeah. So then I have to take the, so PR cross PQ is going to be equal to I, J, K, and -2, -3, 1, and 1, 2, -2. And we're going to get, let's see if we can do this fast. 6 minus 2, is that right?
Yeah.
4i. This minus this, 4 minus 1, which is minus 3j. And then this minus 4 plus 3, is that right? Minus 4 plus 3. Minus 4 plus 3 makes -k, right? So this would be the cross product. And then, so the area of the parallelogram adjoining those two adjacent sides, okay, makes, so that area of a parallelogram that looks something like that is going to be the square root of 16 plus 9 plus 1, which is equal to the square root of 26, okay? And that's how you find the area of parallelogram. But it can be kind of tricky to find out which are the adjacent sides. But I think we'll tell you on the quiz I gave you. I tell you which are the adjacent sides. But for a triangle, which I will give you, how would I find what are the adjacent sides in a triangle?
Half the area of the.
Exactly. Okay. So remember this when you're doing homework. Hey, take those out. I don't care. It's rude. Okay. So if you did that in a college class, the teacher would kick you out of the college class and tell you.
I think the college professor would be more, would think that I would be more concerned that I wasn't getting what I was paying for,
Okay.
but.
Okay, let's not have that argument. Anyway, you're not allowed to have electronics in class, or I will teach you. You're breaking the rules. So with a triangle, it doesn't matter which two sides you pick because every two sides are adjacent, right? This side's adjacent to that, that side's adjacent to that, that side's adjacent to that. So I could cross this with this, and the area of a triangle is half the area of a parallelogram, right?
Yeah.
So I could take any two sides of a triangle, cross them, take the magnitude, and then divide by 2, and I can find the area of a triangle in space. Isn't that cool? All right. So I do have something on the area of a parallelepiped, the volume of a parallelepiped, but I'll teach you at the end of the period. So you could start on your homework.
Well, can we just get it over all?
Yeah.
Get it over with?
Yeah.
Yeah. I'd rather do it now.
Rather do it
Yeah.
now, okay? Okay, this will just take a second anyway, and it won't hurt that much. So the triple scalar product, last thing, triple scalar product. I already kind of told you what that was. What it is, where did it go? It's U dot V cross W, okay? Which we already said is equal to U cross V dot W. So either way you look at it, it's equal to, okay, U1, U2, U3, V1, V2, V3, W1, W2, W3. So in this case, all of these things are numbers because this is going to return a scalar value. It's going to return a number, okay? And so this is a scalar, meaning it's a number, and it turns out that the absolute value of this thing, okay, absolute value of that, absolute value of this U dot V cross W is going to be equal to the volume of a parallelepiped. You know what a parallelepiped is?
Like a 3D.
3D. Yep, it's like a 3D with sides U, V, and W. Okay? So a parallelepiped, it's like something if you were to go like draw a parallelogram. Let's see if I could draw one. So here's a parallelogram and be kind of leaning over, you know, like this, kind of. All the sides are, I don't know how to draw it. You know what I mean, right? Something kind of like a pushed over box, right? Or it could be a perfect, you know, all the angles could be right angles, but in most cases it won't be. It's a box that's kind of pushed over the side. So if I know this is one vector, this is another vector, this is another vector, and I describe each side as a vector, if I take the dot product of the cross product of either two of those vectors and take the absolute, that's going to give you a quantity, and it'll either be negative or positive. It gives you a negative one, then you make it positive. It gives you a positive one, you leave it positive. And that would give you the volume of that box in space. Isn't that cool? So that's it. That's all she wrote. So I'm going to stop and put your homework up here. I've only talked yet for 33 minutes.